Oh, hi, Christina. How are you?
Hi, how are
Oh,
you?
good. Let's see. Did you have a nice weekend?
Yeah, it was good. How was your
Oh,
weekend?
good. Yeah. Did you, what time does your class start today?
My chem classes,
Yeah.
they start Tuesday, Thursday, so they're from 10 a.m. till like 1 p.m.
Oh, I thought it started today for some
No,
reason.
no, no,
Okay.
no. Yeah, they do start. I'm in the center campus, so it's my first time ever like being in person. So I'm like kind of nervous, but like I'm not like that nervous, So like
Yeah. Yeah, because especially since there's the lab part,
yeah,
that's why probably, but I know that the chemistry labs had a hard time being online. I mean, there are virtual labs, but it
yeah.
just isn't the same. I talked to one chemistry instructor who said that when people had to come in, they people were like breaking things because they had never done it in person before and they didn't know.
Yeah,
I know that like you can watch somebody do something, but if you uh haven't done it, like it can be a little bit difficult. So
yeah. I'm taking Chem 1050, like the basic one, because I just need to take the second part of the next level of chemistry.
oh, okay, yeah,
It's a transfer credit to Wayne. So it takes over the chemistry class for Wayne, so it transfers. So
yeah,
yeah.
no, that makes sense. Like it just yeah, I let's see. uh Oh my. All right. Let's see. Let me look at the page that we're on because I'm telling you, like, oh, yeah. Did you have any questions, Christina?
No, actually, it's pretty easy. I got 17 questions into the practice quiz, so it's pretty simple. Majority of it's just formulas.
Yeah.
Yeah, so it's pretty easy.
Oh,
Yeah.
so you got through 17?
Mm-hmm. I
Okay.
basically like kind of taught myself, not taught myself, but like when there's a detailed like work if you get the question wrong.
Yeah.
I kind of just like looked at that and then like looked at the formulas and then looked at the trigonomic sheet you also attached.
Yeah.
Yeah.
Oh,
So
well then, yeah.
there's some where we stopped at. There are like three, four questions that I didn't really try because I was like, I just want to see you do it first and then I can go from there.
Okay. Yeah. Like that's, yeah. Then why don't we can start, like, which one? Do you remember which ones?
It was the one where um one second. It was the one where one second, I just have to see for a second. It wasn't question six because I think we passed that one.
Yeah. So maybe like,
It was the one where it was like it's like sine and then it's brackets and then it's like tan and then something else and then brackets. I think it's that one. Yeah, this one. That's the one.
yeah, okay. So yeah, I figured that like seeing a few more of this type would be helpful,
Yeah, because
just because,
the one that is just like sine and then 2 tan -1 with the parentheses. Those are like really easy for me. Like that's like I understand 100%. But this one I was like, I don't really know like how to go from here.
yeah, I completely understand that. So we can start here and then like go from there with, if there's some things that you already feel like then we'll skip to some of the harder ones. But I'll say that but you're right. Like some of these are easier if it's just using
Yeah,
the formulas.
like the ones with like arctan, like that's really easy. And then the
Yeah,
ones where it's like tan B, find sine B B over 2, like those are really easy as well.
yeah, I get that. So okay, so this one, all right, so the thing with these types of problems is whenever you see the inverse, like sine inverse or the tangent inverse, then you need to remember that those mean that these are actually they're giving you an angle. So that means that, in other words, the it's saying that in a sort of different type of, I guess, a different type of way, that is A and then that is B. So the formula for the tangent of, well, I'll write it here like it was, they use what, probably in the book, I'm gonna use the same variables because I'm sure that they use, yeah, alpha and beta. So alpha minus beta is tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. So this is where I feel like it becomes a little bit more tricky because this is what gets substituted in for the alpha, and then this is what gets substituted in for the beta. So you have a sort of complicated expression when you write it all out because it's tangent of whatever that was. So sine inverse of negative 84 over 85, then minus tan of tan inverse of negative 63 over 16, and then 1 plus tan of the sine inverse of negative 84 over 85, and then times tan of tan inverse of negative 63 over 16. So I I feel like that's where it just makes the problem look a little bit bigger than it actually is. And that's what, that's what always I think gets people, but it's just substituting those in. But then other than that, though, I really feel like this is just something where you can like find these fairly easily, but because if you look at it, like the only things you need to find are this and then this. So you need to find the tangent of sine inverse of negative 84 over 85, and you need to find the tangent of the tangent inverse of negative 63 over 16. And of course, right, if this is an angle that actually exists, which it is, then these actually would cancel out and you would have negative 63 over 16. So that's actually the easy one. This is the harder one. So do you have any questions so far? Okay, so yeah, so like that's what I mean is like just like the number 6, like if you have sine of sine inverse or cosine of cosine inverse, those are the easy ones that will cancel out. But then this one is a little bit more difficult. So what I would do is just do it like in the previous, chapter and just then look at this part and then just say, well, all right, sine inverse means that you're in quadrant 1 or quadrant 4. So that would be quadrant 1 if it's positive, but quadrant 4 if it's negative. So then if I look here, this is actually negative, so I'm in quadrant 4. So then since I know the quadrant, then I can just draw the quadrant 4 reference triangle. So this is the quadrant 4 reference triangle. And then if you remember how this works here, then, oops, sorry. I dropped my highlighter. So then the sine of theta will be the negative 84 over 85. So that's opposite over hypotenuse. So this is the hypotenuse. That's the opposite side. And then you can use the Pythagorean theorem to find the side here. So then that really isn't too bad. It's just a squared plus b squared is c squared, as you would usually go through all of this. And so then you have a, let's see, it doesn't really matter which one is which. So a squared plus negative 84 squared is 85 squared, except for c is the hypotenuse always. And so then you're left with, I know that I don't actually know what it is. So I know the final result. So I'll just do these real quickly. So a squared plus 7,056 is 7,225. Subtract. So a squared is 169. So a is plus or minus square root of 169. So plus or minus 13. But then I know that it has to be positive because it's over in quadrant 4. So that means that this adjacent side has to be positive, because this point right here is positive 13, negative 84. So from that point, what happens is, right, you just go ahead and find the tangent of that theta. So the tangent of that theta is opposite over adjacent. So that would be the negative 84 over 13. So do you have any questions about that? Okay, so then if I substitute all of those in, then this would be, let's see, so that part right here was the negative 84 over 13. This part was negative 63 over 16. This is 1 plus that, and then that will end up being the negative 84 over 13. And this will be the negative 63 over 16. So then what happens now is you just put it all together there. And so, yeah, well, the common denominator happens to be 13 times 16. So that will be 208. So if I were to just, and I, like I always wonder like what people are thinking sometimes, but I probably would just clear the fraction like that. So 208 by every term. So if I do that, then 208 times negative 84 over 13, that will be, uh, what is that? That will be, yeah, so negative 1344, then two negative make a positive, so plus, that will be 819, then over the, let's see, 208, and then plus in 84 times 63, 5292. So then you end up with if you add those together, and this is, I think, the harder part sometimes, is just making sure you don't, even when you're going through all of this, like you accidentally miswriting a number, but it ends up being over 5,500, and that's okay. Or you could reduce to negative 21 over 220. Either is really okay at that point because you went through all of that work. But or you could just go through and, like I don't know, like which way is easier, but it depends on what you see. But I'll tell you that if you were to do this using the method of formulas rather than the just drawing the triangle like I did, then you see like they get this really, really messy fraction because of it. So like I don't really want to like deal with those messy fractions. So I kind of prefer the triangles for that reason. But do you have any questions about this one? Okay, then so
Yeah.
I'll do number 8 also, because number 8 was another one of these types. But the issue with number 8 is that it actually just doesn't really give you much information about it. It just sort of looks like this, but there's no numbers in there, just an X and a Y. But it's not really as bad as it probably seems, because remember, if you have the inverse function, then it's an angle. So I'm just going to do A minus B again. So whatever this is A, and whatever that is B. And then I write out the formula for, or the identity for, the cosine of alpha minus beta. So that actually is just the, where is it? I don't actually know why, if this is the quickest way, but this is the quickest way. All right, cosine alpha, cosine beta, plus sine alpha, sine beta. So then just substitute then this in for the alpha, and then this in for the beta. So this will end up being the, when I substitute this, cosine of tangent inverse of x, then cosine of cosine inverse of y, and then plus sine of tangent inverse of x, and then the sine of the cosine inverse of y. So this, I think, is where this is it's definitely a lot to, I guess, like, in my opinion, take in. So I just go like step by step and then just think about what is right, what is being asked. And so I will say though that because you don't know what X and Y are, you have to be a little bit careful, because then it could be in either quadrant. So if you look at this, this is tangent inverse. So tangent inverse, if you remember, that one could be in the, where is it? Yeah, quadrant 1 or 4. So yeah, quadrant 1 or 4. And then cosine inverse, that's in quadrant 1 or 2. And then tangent inverse again, quadrant 1 or 4. And then cosine inverse, quadrant 1 or 2. So I feel like that's really where the issue is at, is that you have to, right, think about where the angle is going to be at. So I'm gonna sit down for a second. All right, so then a let's just do this one first. So this is going to be the triangle for the tangent inverse of X. Now, remember that that means that the tangent of theta is equal to X, but that's actually X over 1. So that's opposite over hypotenuse. So I I do want you to see that right there. So since this is in quadrants 1 or 4, that means I could draw it like that, or I could draw it like that. So that's the issue right here, is that I don't know what is actually right. I don't know what's actually happening. So this would be right. This is what the X would be if X were positive, and this is what the X would be if X were negative. So, but since you don't know, then you draw, you draw both of the triangles, and then, so, yeah, so since you don't know if the X is positive or negative, then just draw both triangles. And so honestly, like, if it weren't for the fact that this is something that is more of a like a skill that you need for calculus, I wouldn't actually, like, I wouldn't actually say like this was as uh important, but this is a specific to calculus type of skill. So then the hypotenuse is the 1. So that means that this is 1 and this is 1, which is actually good, because the hypotenuse is always going to be a positive, whether it's, no matter what quadrant it's in. So that's 1. And then you can find this missing side using the Pythagorean theorem. So then what you do then is say, well, a squared plus b squared is c squared. So then you have a squared plus x squared is 1 squared. So then a squared is 1 minus x, sorry, 1 minus x squared, right? Yeah, and I don't actually, sorry, I thought this said something completely different. I thought that said something completely different. I think what I read, I know what I read. This is obviously opposite over adjacent, but I know what I read because I read it. I I read sign here because I know what happened. I was looking at, what was I looking at? I was looking at sine of alpha and didn't even notice that said tangent. So yeah, don't ignore what I said then about that being the hypotenuse. I know what I said here, but I know what I read. I was reading sine of alpha and didn't even remember that that's what I wrote. So I apologize. So X over one, but this is positive one no matter what. So you can still find the missing side here. So it is actually, I don't know if this is out or I think it just means this is out. Yeah, hold on. Okay, so I don't actually know if this is a, yeah, so that's sorry. So that one is actually, if I look at it, then I have 1 squared plus x squared is c squared. So c is equal to square root of 1 plus x squared, but it still applies that the hypotenuse is still always positive. So I don't need plus or minus. So I I don't need the plus or minus since the hypotenuse is always positive. So then I wouldn't normally try to fit this in right here, but I didn't have another piece of paper right away. So do you have any questions yet? Okay, so then what I would say then is that since you want the, now again, there's two things you actually want here, and one of them was the, one of them was the cosine of what you just found, and the other one was the sine of what you just found. So I would just go and find both of them at the same time. So if I did that, then the cosine of this theta or cosine of tangent inverse of x then will be the adjacent over hypotenuse. So that will be the 1 over that square root of 1 plus x squared. And then the sine of theta or sine of that tangent inverse of x will be the opposite over hypotenuse. So that will be the x over that square root of 1 plus x squared. So those ones actually are not that uh, difficult to find, hopefully. So then you have to move on and then make the, what's on here. So then you want to actually have the triangle for the cosine inverse of y. So then let's see. So then that one, now if you look here, that is in quadrants 1 and 2. So you might have that triangle or you might have that triangle. So it might be either of those. And so if you actually do that, then again, you don't know if y is positive or negative. So since you don't know if the y is positive or negative, then just draw both triangles, because you don't want to accidentally, make that mistake here. So then this right here similarly is cosine of the theta is y, or y over 1. So that's actually adjacent over hypotenuse. So here's the y, here's the y, here's the 1, here's the 1. And then you can find the missing side using the Pythagorean theorem. But these, even though they're two different triangles, they have the same length up here, because it's a value that is actually like going up. Now, all right, so this is where I like I do want to, I didn't acknowledge this before, but yeah, I do want to say that because this X here is just, it could have been replaced with any letter like W, R, S, T, but it's not X in the normal way that you would say X and Y, because the this is still the X direction, but you're going up whatever that number is up that way. And then this is still the Y direction, but you're going up whatever that amount is that way, even though it's labeled Y, that's not the same as like that. So Y, like the Y axis Y, and the other one, the X wasn't the same as the X axis X. So I think that that is part of the way that a problem like this might try to trick you, like get you to your mind to sort of mix up the variables by accident. But these are both positive lengths. So in particular, the same positive length. So then you can find using the Pythagorean theorem. So then this is actually the one where you are looking for the, I don't know what's going on here. Yeah, this is actually very odd that like all of a sudden none of the whiteout is working, because I just got this one out of the, unless it this one. Yeah, okay, that one's the one that, all right, so find using the Pythagorean theorem. So a squared plus b squared is c squared. So then what do you have? You have a squared plus y squared is 1 squared. So you have a squared is 1 minus y squared. So a is, oh, sorry, I may have said that was the hypotenuse, but we already knew it was 1. So if I said that, I didn't mean it, because it obviously wasn't 1, but the square root of 1 minus y squared. So this is square root of 1 minus y squared. This is square root of 1 minus y squared. So then if you go back to what they were asking you for, they wanted you to find the cosine of that angle and the sine of that angle. So you really then need to find the cosine of that angle, but I already know that was y, and then the sine of that angle was the opposite over the hypotenuse. So that will be the square root of 1 minus y squared over 1, or just square root of 1 minus y squared. So then if I substitute it all back in, then you have, and this is where, right, you have to like keep track of all the things that you found. But the first thing that you found was the 1 over the square root of 1 plus x squared. Then you found the cosine inverse of y, so y, then plus sine of tangent inverse of x, so x over square root of 1 plus x squared. And then you have the square root of 1 minus y squared. And then because this is a common denominator now, then you would just write it, just to make it a little bit more simple of an expression, just write it all over the same denominator. So y plus x times the square root of 1 minus y squared. So that is that. But again, like I feel like this is one of those where it can just, like it can be a little bit tricky because of the variables like x and y, but I don't feel like it's impossible. It's just it can be tricky. So do you have any questions or anything that you want to see again? Okay, so then let's see. So yeah, so if you now, I will say then, since you said you did some of these, Christina, like I said, I want to go to some of the ones that you may have more trouble with. So I'll write. Well, here, did you want one like this, or did you get the the double ones?
I did all of these. They're all pretty easy.
Okay, so
Question 11, yeah.
the double ones are okay.
Yeah, question 11, yeah. I did question 11. I did question 12.
Like that one.
Let me see. Cos 2 alpha.
Yeah.
Let me see, question 11. I don't think I've seen the one with the theta and alpha, but I did do question 11. Let me see, actually, I can check my
Here, let me check, because I can bring up your practice quiz, I think, and probably like also see which ones you've done, because it saves them for me
okay,
too,
sure.
just in case like anything goes wrong on your end, like then I would know what you've done. So like I do like that part of this, because then like it's less like, like if for some reason something like happens, it will be.
Yes, I haven't seen the one with alpha in it yet, or the question, like I'm looking at question 11 right now. It's like if sine was negative 35 over 37 with alpha in quadrant 4, then find cos of 2a. I think it's just written out, or my
Yeah,
yeah. Then
sometimes
never
it's
mind,
like,
never mind.
sometimes it's just written out. So like,
Yeah, that's why I was just like confused for a second. But
yeah, so I'm guessing that like you
is
got to like, yeah, you did get to like 17 then, right? Yeah. Yeah, so we can start there then.
yeah, I did 17. It was pretty easy, and then
Okay.
I question 18 and 19, and then
Yeah.
I really just had my main questions on questions 18 through 22. That's about it. And then the rest are pretty simple.
Yeah, then we'll start at 18 then. And so, and then on Wednesday, like if there's any like things like that we still need to finish up, or anything you decide that you want to go back to, we can do it then. It's
Okay, perfect.
fine with me. And then 18. There's one like 18, just so that like, okay. Yeah, so like these type are the half angle ones. So I feel like, like sometimes the ones that I get will be uh, a different function, but same idea because I just print out a version of it. So if I have one that looks like this, and we can, like I said, we can always do another one on Wednesday, but it's if sine of theta is negative 36 over, let's see, uh, yeah, negative 36 over 85. And pi is less than theta, less than 3 pi over 2. Then find the sine of theta over 2. All right, so then this here, these formulas actually come from the next section. So they're the ones on page, where is it? I don't actually, I'm looking for them, but they're probably, yeah, 8.4 somewhere. So then I would still start out by writing down the formula for the half angles. So that one, and I'm trying to see which version that they gave you because I already know that. Yeah, okay. Yeah, they gave you this version of it. And so it's first, then the identity for sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta over 2. So there's a reason why then, right, that they would give you the plus or minus there. And it's just like before that sometimes it might be positive and sometimes it might be, negative. It all depends on the quadrant that it's in. So I now I really feel like this is one of those where yeah, that it actually gets a little bit tricky, but it all depends on what information that you want to know. But what I will say, though, that you want to recognize that theta, right? Theta is actually right here. So theta is between pi and 3 pi over 2. So here pi, 3 pi over 2. So theta is, right? Theta is in quadrant 3. So I would just, again, keep that in mind right there. Now, all right, here's where it gets tricky though, right? So do you see this plus or minus here? So the issue is that this is theta over 2. So then you have to take the limit right here, or the bounds for theta. And because it's divided by 2, then you have to divide all of these by 2. So divide all by 2. So then you have the pi over 2 is less than theta over 2 is less than 3 pi over 4. So that would be the theta over 2. So this is, I think, the part where I understand why people get a bit confused by it. That's why I would just draw it out. You know what I mean? Like otherwise, like I feel like you don't see it. So then the pi over 2 is actually right here. And then 3 pi over 4 is actually right here. So that means that, right, the theta over 2 is in quadrant 2. So that's one thing that I would notice. So theta over 2 is in quadrant 2. So then here is why I want you to sort of see both of these, because you're going to use this diagram to figure out whether this is positive or negative. And then you're going to use this diagram to find the cosine of theta, because that's what they, right, that's what they told you about theta, but they didn't actually tell you anything about theta over 2. So you're going to use this diagram to tell whether that is positive or negative, and this diagram to figure out cosine of theta. So as long as you can keep those sort of separated, then that's what's going on. So since the sine of theta is actually positive in quadrant 2, then we use the positive square root here. So that's where that part comes from. And then now that we know what the sign is that we're going to use, and by the way, I'll say that the book actually goes for like figuring out the cosine of theta first, but my personal feeling is that since you are since you're reading it from left to right, you would always like figure out whether that positive or negative and then look at what's over here next. So like it's sort of like they did it as a bit of an afterthought. They just said, oh, by the way, like we have to remember that that could be positive or negative, but you already know if you do it first. So I would just do that. Do you have any questions so far? Okay, then let's see. So then if we look at this, it says that sine of theta was negative 36 over 85. So that's opposite over hypotenuse. I don't know why that doesn't look over like 85, but it's 85. So 85. And then if I draw my triangle in quadrant 3, so down here like this, then the opposite side is the negative 36 in hypotenuse 85. And then I can find the missing side, find missing side using the Pythagorean theorem. So if I do that, then, and you know, like you could use formulas, but again, my thought is like, don't like do, let me move that, like don't, you know, use other steps if you don't absolutely need them. It's just unnecessary. And so then let's see. So we have a squared plus b squared is c squared. So we have a squared plus a negative 36 squared is 85 squared. So a squared plus the negative 36 squared. What is that? Like, yeah, so 36 squared. Yeah, 1296. And then 85 squared is 7225. So then subtract those. And you have a squared is 5929. And then you take the square root and you're left with 77. So A is plus or minus the square root of 5929 or plus or minus 77. So this is actually negative over here. So it's negative 77. So therefore, the cosine of theta is, so therefore the cosine of theta is adjacent over hypotenuse. So it's the negative 77 over 85. And so then we substitute that in. And so we have the sine of theta over 2 is equal to, we wanted the positive square root of 1 minus cosine of theta over 2, but cosine of theta was that negative 77 over 85. So that's square root of 1 minus a negative 77 over 85. And again, like, just be careful when they're asking for these exact answers. I know that it's a pain, but I, like, I would hate for you to like not pay attention to something small like that and it would end up being worse. So I probably would do the same thing that I usually do, which is multiply every term by 85 just to clear the fraction. So we have square root of the 85 plus 77 over 2 times 85. So it is square root of 162 over 170. So that should be okay. Yeah, because it says you do not need to simplify or reduce the fraction. So that would be okay. So do you have any questions?
No,
Okay.
it's pretty easy.
Yeah, like I feel like, like as long as you on these ones make sure that you get the plus or minus stuff correct, it should be fine, but it, you know, uh, hopefully it's not, doesn't end up being too bad. So then let's see, where is the next one? Because I feel like these are okay. So 19 was, let's see, if the tangent of phi is 33 over 56 and pi, oops, sorry, I don't know why you can't see that. I don't, it's okay. And then the pi is less than phi, less than 3 pi over 2, then find the cosine of phi over 2. All right, so then this one is similar. So if I use the formulas and again, like they're over here. So it's really like it's a plus or minus again. So this is the identity for cosine of phi over 2 is plus or minus the square root of 1 plus the cosine of phi over 2. So then here, I don't know why this is actually in the way. Okay, so then like the same thing as before, we need to draw like two diagrams. So one of them will be used to figure out whether this is plus or minus, and then the other one will be used to find the cosine of phi. So if I look at this, then I have to do the same thing and divide these all by 2. So I mean, honestly, like if you do that, then you end up with the same diagram as before. It's just that, you know, it's only because they gave you the same like quadrant to start with. So if that didn't happen, then of course it could end up in a different quadrant. But since this is actually the same sort of thing here, that this is the theta, or sorry, phi over 2, and then this one is the phi, then that means that therefore, then where is it? Because this is actually, I was gonna label these, it's really just the same diagram as the last problem, but all right, so then that's all it is. So just remember that the difference in this case is that phi over 2 is in quadrant 2, but you're using the cosine this time. So since the cosine is negative in quadrant 2, you're going to use the negative square root. So I think that's part of the like the lesson to learn from this here is like it's not always just say like positive because it's in quadrant 2. It has to do with whether this is a cosine or a sine of like something over 2. So then over here, the phi is in quadrant 3, but then you need to remember that the cosine of phi is going to be negative in quadrant 3. So whatever you end up with for cosine of phi should be negative, and since it's in quadrant 3. So if you put it all together, you were given that tangent of phi is 33 over 56. So that's a sorry, I was gonna say it's opposite over adjacent, but like I wrote that too high, so I'm just gonna rewrite it. Opposite over adjacent. So then here is the reference triangle in quadrant 3 here. So I really don't think that this is difficult to draw once you get used to the situation here. But if you have the opposite, which is 33 and adjacent 56, you can find the hypotenuse easily. So find the hypotenuse. So you use the Pythagorean theorem. So a squared plus b squared is c squared. 33 squared plus 56 squared is c squared. So I'm just tell you what this number is. It's 4,225 is c squared, but then you take the square root of that, and because the hypotenuse is always positive, you can just say that that is actually just 65. So then therefore, what you are trying to find is that cosine of phi. So that's adjacent over hypotenuse. So in and just be careful because this is negative, right? And that's negative. I didn't actually like put negative there, but I I also though like remember that's why I always identify the whether the final answer should be positive or negative first, because look at what happened here, right? Because like a negative divided by a negative is a positive, and that's why the tangent was positive. If you didn't know that, or at least like think about it, that should be negative, you may have accidentally forgot to put or forget to put the negative there. So I just would do that. So negative 56 over 65. And so therefore, then the cosine of phi over 2 is actually, we said it was negative, and then we need the square root of 1 minus 56 over 65 over 2. And from here, yeah, I guess I would just recommend doing this very similarly to the last one. So you just 65, 65, 65. So you have negative, then square root of 65 minus 56 over 130. So it ends up being a, is it like or 9? Yeah, so negative square root of 9 over 130. And again, you don't have to reduce the fraction. So I would just, leave it like that. But do you have any questions or anything? Okay, yeah, like I said, like these aren't going to be too bad, but I can see the issue. So the rest of these though, now, yeah, I'll admit that these are a bit tricky, like 20 through 22, but I don't think that they're going to be impossible for you. So they're like if we use the formula as 20, that was, where was it? Yeah, and these might actually end up, well, I guess it depends because it might seem like it's easier, might not. So it's find the tangent of 1/2 times the arctangent of negative 16 over 63. And so I will say though, whenever you see the arctangent or the inverse tangent, then you need to think of it as being like an angle. So we could call it A. And so then the identity for tangent of 1/2 alpha or 1/2 A, that was the, now again, there's two ways of writing it. So actually a couple. So plus or minus the square root of 1 minus cosine of theta over 1 plus cosine of theta, or 1 minus cosine of theta over sine of theta, or sine of theta over 1 plus cosine of theta. So the real advantage here is that if you actually if you actually decide to use one of these, then you don't have to Yeah, I guess my point is like you don't have to worry about the plus or minus here. You just substitute in the values, right? So it all depends, right? I mean, the only advantage to this is that you only need cosine if you do this formula. So this one only requires the cosine of theta, but you have to figure out whether the square root is positive or negative. So that's a disadvantage. So I would honestly, like I said, it's really up to you which one that you pick. So I'm gonna say that let's just use this one. Right? It doesn't matter, right? And so then if I do this, then remember that if I have arctangent of negative 16 over 63, then the arctangent is in we did this actually, so I can tell you again, but I guess it doesn't really. I guess it doesn't really matter, but I guess I was gonna say it again, but yeah, I don't know why yeah, anyway, I was gonna show you where we did before, but anyway, this is arctangent is in quadrant 1 and 4. So I don't feel like that's actually like is a big issue really. Oops, sorry. So then if you draw this, because it's negative, then you use quadrant 4. So that's the same as before. And then you draw your triangle down here. And then the tangent of theta is negative 16 over 63. So that is opposite over adjacent. So if this is your theta here, then opposite side, negative 16, hypotenuse we'll have to find, and then adjacent 63. So then while the hypotenuse is actually can be found using a squared plus b squared is c squared. And so what we're left with is 63 squared plus negative 16 squared is c squared. And that's a grand total of 256 plus 3969 is c squared, or 4,225 is c squared. But when you take the square root, then you only need the positive one since it's the hypotenuse. So this is 65. And then, like I said, you can go ahead and either, right, you can either use the first, second, or third formula, but let's just use the second one, which means that we need the cosine of theta, which is adjacent over hypotenuse. So 63 over 65, and the sine of theta, which is the opposite over hypotenuse. So that will be the negative 16 over 65. And so therefore, the tangent of the 1/2 arctangent of the negative 16 over 63 will be, now remember, it was 1 minus cosine of theta over sine of theta. So the cosine of theta is the 63 over 65. And then the sine of theta was the 16 over the, yeah, the 16 over the, what was it? 16 over, sorry, negative 16 over 65. I couldn't find it. Negative 16 over 65. So then if I go ahead and find a common denominator, 65, 65, 65, then I have the 65 minus 63 over negative 16. So that's negative 2 over 16. So negative 2 over 16, or if you want, negative 1 over 8 is fine too. But like I said, you don't have to reduce any of these. So I would just like go with, go with that. But do you have any question about these?
No, it's pretty simple. If the next two questions are like similar, then I think I'll be okay.
Okay, yeah, so that's what I was going to say, Christina. So
Yeah.
like, I will say like, if, so, yeah, so I figure then we can just like, let me stop then.
Yeah.